The final round of notes. We have 3 story problems. I'm showing you the first 2 story problems here. You might want to pause it and write those down. So here we're looking at problem 3 is tuition varying directly as the number of credit hours taken. Hey, you guys are living this out right here, aren't you? Cost of 16 credit hours, 2,000. What's the cost of 10 credits? So we have all the clues that we need to do exactly what we did the last round of notes. I see that we are looking at direct variation. Direct variation, we said, is y equals kx. In this case, what do I have before the word varies? Is the word tuition. So that means that my y variable is really the word tuition. So my tuition equals a constant, and it says it directly vary as the number of credit hours taken. So we just need to pick a word there, credit or hours. I think in the question down below we're talking about credits, so I think I'm just going to use the word credits. You don't have to write out the words. You can just pick your favorite letter, T and C. In fact, that's sometimes what I do. So here we go, the cost of 16 credit hours. So that 16 that we have right here is going to go under credits. And notice that that's connected in the same sentence with $2,000. So 2,000 equals my constant times 16. So to find what my constant is, I'm going to divide both sides by 16. And when we divide my 16s, they cancel on that side. And when I divide this side, 16 goes into 20. 1 time carried the 4, 2, 8, and 5. So my constant is 125. In this case, if you think about this, when we plug this back in, my tuition is a constant times the number of credit hours. This 125 actually stands for the cost per credit, $125 per credit. Put a dollar sign in there if you want. It doesn't really matter. So now we want to find out what is the cost of 10 credits. Well, I think you guys can kind of do that in your head, but formally, my tuition equals 125 times 10 credits, which then is going to be $1,250. So that is our answer. So all we did is we just converted from a story problem, broke it down, found direct variation, came up with our terms, tuition and credits, and plugged our numbers in, solved, found something meaningful as an equation, plugged in the 10 that was in this case, hey, well we know how much it is with 16 credit hours, how much with 10 credit hours, and now we know. Okay? Hopefully fairly painless. Let's look at problem 4. The speed of a car varies inversely with the car's weight. If the car weighs 2,000 pounds and travels 60 miles per hour, what is the speed for the car at 3,000 pounds? Well, here we're talking about inversely, that is y equals k over x. And what comes before the word varies? Speed. So the speed of the car, so in this case s, speed, equals my constant divided by whatever comes after the word varies, the car's weight. So I'm going to use weight. So speed equals constant divided by weight. In the story problem, I see the 2,000 pounds goes with the 60 miles per hour. So I just need to get things in the proper place. 60 miles per hour goes over here. And my constant k divided by my weight of 2,000. So now I need to multiply both sides by 2,000. Cancels there. My constant in this case looks like it is 6 times 2 is 12. There's 3 zeros there and a 1 zero there. It's a total of 4 zeros. So my constant is $120,000. Or not dollars, 120,000. So if I write this, I have speed equals a constant of 120,000. I keep wanting to say dollars. I guess I'm hoping someone's going to give me that money soon. So speed is 120,000 divided by weight. Now the question is, what is the speed for the car at 3,000 pounds? So if we take and plug my S equals 120,000 divided by 3,000, then my speed, in this case, zeros cancel. I'm left with 120 divided by 3, so that's 40. The units for my speed is miles per hour, so that's what I'm going to put with it. So my speed, 40 miles per hour. Let's look at the last one down here. The volume of a sphere varies directly as the cube of its radius. A sphere with a 3-foot radius has a volume of 36 pi cubic feet. How much air is required to fill a beach ball with a radius of 1.6 feet? Here we have the word directly, or direct variation. So that's going to be y equals kx. Can you guys see that? So y equals kx. So what comes before the word vary is volume. So I'm going to say that my volume equals my constant k times what comes afterwards, the cube of its radius. So I'm going to write this radius. The word cube means an exponent of 3. So my volume equals my constant times my radius to the 3rd power. So here we have an example of a 3-foot radius with a volume of 36 pi cubic feet. And those go together, they're in the same sentence. So my volume, 36 pi, and my radius is 3. So I plug that into my equation. 36 pi equals my constant times 3 to the 3rd power. So now what's left is that I need to solve for k. 3 to the 3rd power is 3 times 3 is 9, times 3 is 27. So that's 27. Divide both sides by 27. And this cancels on this side. And I'm left with 36 over 27 times pi equals k. 36 over 27, that seems like it can reduce. In fact, I noticed that 9 can go into both of those. So if I divide the top by 9, I get a 4. Divide the bottom by 9, I get a 3. So 4/3 pi equals my constant k. So my equation, really, I'm going to plug that back in up here, is volume equals 4/3 pi times my radius to the 3rd power. So how much air is required to fill a balloon with a radius of 1.6? Well, let's plug that in. 4/3 pi, 1.6 to the 3rd power. Then we just need to get our calculator and plug all those in. So 4 divided by 3 times pi, let's just use 3.14, times 1.6 to the power of 3. If you plug that all in at one time, you're going to get an answer, a volume of approximately, that's a little squiggly for those of you that may or may not like to do that, lets us know we're rounding it off, 17.15. And if we go back over here, we can see originally we have 3-foot radius, and our answer is 36 pi cubic feet. So 17.15 cubic feet. So I'm going to put that like that. The other thing that we might want to do is to not have multiplied that by the decimal 3.14. I can't remember what the book does. So you might also see in the back of the book, it might leave it about 5.46 pi. So they might leave it without doing anything with the pi. They just might go 4 divided by 3 times 1.6 to the 3rd power. And I can't remember exactly which way the back of the book does, but either way, it works out something like that. So that was, oh, you can't see my cubic feet there. Feet with a little 3 above it. Time for the final classwork.